Download this code from codegive.com, link in the description below. OK, let's dive into building a text-to-SQL agent for smarter database queries. This is a fascinating area blending natural language processing, NLP, with database interaction. We'll cover the core concepts, architectures, tools, and provide a detailed code example using Python and popular libraries. Introduction: the power of text-to-SQL agents. Text-to-SQL agents, also known as natural language to SQL systems, bridge the gap between human language and structured databases. Instead of requiring users to write complex SQL queries, they can simply ask questions in plain English, and the agent translates these questions into executable SQL. This significantly lowers the barrier to accessing and analyzing data stored in databases. Why are text-to-SQL agents valuable? Accessibility makes database information accessible to non-technical users. Efficiency speeds up data retrieval compared to manually crafting SQL queries. Automation automates repetitive querying tasks. Data-driven decisions facilitates easier exploration of data for informed decision-making. Challenges in building text-to-SQL agents. Ambiguity. Natural language is inherently ambiguous. The same question can have multiple interpretations. Semantic understanding. Understanding the meaning of the user's question and its relation to database schema. Schema linking. Mapping words in the question to specific tables, columns, and relationships within the database schema. SQL syntax generation. Creating syntactically correct and semantically accurate SQL queries. Complex queries. Handling complex queries with joins, aggregations, subqueries, and conditional logic. Data type awareness. Understanding the data types of columns to generate appropriate SQL operators, example using equals for equality, for greater than, etc. Contextual understanding. Remembering previous queries and user interactions to refine subsequent queries. 2. Architecture of a text-to-SQL agent. A typical text-to-SQL agent architecture involves several key components. 1. Natural language understanding, NLU. This is the core component responsible for processing the user's question. It typically involves tokenization. Breaking the question into individual words or tokens. Part of speech, POS, tagging. Identifying the grammatical role of each word, example noun, verb, adjective. Named entity recognition, NA. Identifying specific entities like names, dates, locations, and in our case, database table and column names. Dependency parsing. Analyzing the grammatical relationships between words to understand the sentence structure. Semantic parsing. Understanding the meaning of the sentence and its logical structure. This is often the most challenging part. 2. Schema encoding. This component represents the database schema, tables, columns, relationships, data types, in a machine-readable format. This allows the agent to understand the structure of the database it is interacting with. 3. Query generation. This component takes the output from the NLU and schema encoding components and generates a SQL query. This often involves schema linking. Mapping the identified entities in the user's question to specific tables and columns in the database. SQL template filling. Using the identified entities and relationships to fill in a SQL query template. SQL syntax validation. Ensuring that the generated SQL query is syntactically correct. 4. Query execution. This component executes the generated SQL query against the database. 5. Result processing *. This component processes the results returned by the database and presents them to the user in a readable format. Simplified diagram *. 3. Tools and technologies. Python *. The primary programming language for building text-to-SQL agents due to its rich ecosystem of NLP and database libraries. Natural language processing, NLP, libraries *. Spacy *. A fast and accurate NLP library for tokenization, POS tagging, NA, and dependency parsing. NLTK, Natural Language Toolkit, a comprehensive NLP library with a wide range of functionalities. Transformers, Hugging Face provides pre-trained language models, like BERT, Roberta, GPT, that can be fine-tuned for specific NLP tasks. Database libraries SQLite 3 for interacting with SQLite databases, good for prototyping and simple examples. Psychopage 2 for PostgreSQL databases. PyMySQL for MySQL databases. SQL Alchemy an ORM, Object Relational Mapper, that provides a higher level abstraction for interacting with databases. Frameworks LangChain a framework specifically designed for building applications powered by language models, including text-to-SQL agents. Haystack a framework for building search pipelines, which can be adapted for text-to-SQL. Pre-trained models Tapas, table parser, a BERT-based model specifically trained for question answering over tables. RAT-SQL another popular pre-trained model for text-to-SQL. These models usually require more computational resources, GPUs, and more complex setups. Datasets Spider a large-scale text-to-SQL dataset with complex SQL queries. WikiSQL a simpler text-to-SQL dataset that is good for getting started. 4. Code example, a simple text-to-SQL agent using Spacy and SQLite. This example demonstrates a basic text-to-SQL agent using Spacy for NLU and SQLite for database interaction. It's a simplified version, but it illustrates the core concepts. Explanation *. 1. Import libraries imports Spacy, SQLite 3. 2. Load Spacy model loads a pre-trained Spacy model, n_core_web_sm. You might need to download it using Python m Spacy download n_core_web_sm. 3. Create database creates an in-memory SQLite database and a sample employees table with columns ID, name, department, and salary. Insert some sample data. 4. Execute_query function executes a given SQL query against the database and returns the results. Includes error handling. 5. Text_to_SQL function takes a natural language question as input. Uses Spacy to process the question, tokenization, etc. Simple keyword-based logic this is the most basic form of NLU. It checks for the presence of certain keywords in the question, example salary, average, department. Based on these keywords, it constructs a corresponding SQL query. This is extremely limited and won't work for more complex questions. A real-world system would require much more sophisticated NLP. Returns the generated SQL query. 6. Example usage iterates through a list of example questions, translates each question into a SQL query using text_to_SQL, executes the query, and prints the results. 7. Close connection * closes the database connection. Important notes on the code example *. Very basic NLU *. The keyword-based approach in text_to_SQL is extremely rudimentary. It's only meant to illustrate the basic flow. For any real-world application, you'll need a much more sophisticated NLU component using techniques like semantic parsing, dependency parsing, and potentially pre-trained language models. Limited schema understanding *. The code doesn't explicitly encode or understand the database schema. It relies on hard-coded knowledge of the table and column names. A more robust system would need to represent the schema in a machine-readable format and use this representation to guide the query generation process. No error handling *. The code only includes basic error handling for SQL execution. A more robust system would need to handle errors during the NLU and query generation phases as well. No context awareness *. The agent has no memory of previous queries or user interactions. It treats each question in isolation. Advanced techniques for building text-to-SQL agents. To build more robust and accurate text-to-SQL agents, you'll need to explore more advanced techniques. 1. Semantic parsing *. Convert the user's question into a logical representation, example a lambda calculus expression or an abstract syntax tree. Use a parser, example a constituency parser or a dependency parser, to analyze the grammatical structure of the question. Map the logical representation to SQL elements, tables, columns, conditions. 2. Schema linking with embedding techniques *. Use word embeddings, example word2vec, glove, or pre-trained language model embeddings, to represent the meaning of words in the user's question and the names of tables and columns in the database schema. Calculate the similarity between the question embeddings and the schema embeddings. Use the similarity to link the question to the relevant tables and columns. Can use specialized embeddings that are pre-trained on code and schema data. 3. Pre-trained language models, POMs. Fine-tune pre-trained language models, like BERT, Roberta, BART, T5, for the text-to-SQL task. Models like Topaz and RAT-SQL are specifically designed for question answering over tables. These models can learn complex relationships between the question and the database schema. 4. Reinforcement learning, RL. Use reinforcement learning to train the agent to generate SQL queries. The agent receives a reward based on the accuracy of the generated query. This can be particularly useful for handling complex queries with joins, aggregations, and subqueries. 5. SQL template filling with constraints *. Define a set of SQL templates for common query types, example select, where, group by. Identify the relevant entities in the user's question and map them to the slots in the SQL templates. Use constraints to ensure that the generated SQL query is syntactically correct and semantically meaningful. For example, ensure that you are comparing columns with compatible data types. 6. Contextual understanding with dialog history *. Maintain a history of previous user interactions. Use this history to resolve ambiguities and refine subsequent queries. Techniques like recurrent neural networks, RNNs, or transformers can be used to model the dialog history. 7. LangChain and similar frameworks. LangChain offers a framework which allows to easily hook together a language model like GPT-3 or open source models with other components like data loaders, vector stores, etc. You can use the built-in SQL database chain in LangChain, which simplifies the process of building a text-to-SQL agent. Example using LangChain asterisk. Explanation of LangChain example asterisk. 1. Import libraries asterisk imports necessary LangChain modules. 2. Set OpenAI API key asterisk sets the OpenAI_API_ key environment variable. You'll need an OpenAI API key for this to work. 3. Database connection asterisk establishes a connection to the database using SQL database.from_URI. In this example, it's using an in-memory SQLite database, but you can replace it with a connection to your actual database, PostgreSQL, MySQL, etc. 4. Initialize language model asterisk initializes the OpenAI language model, OpenAI. You can adjust the temperature parameter to control the creativity of the model, lower temperature equals more deterministic. 5. Create SQL chain asterisk creates the SQL database chain using SQL database chain.from_LLM. This chain combines the language model, the database connection, and the text-to-SQL logic. The verbose equals true argument enables logging, so you can see the intermediate steps, the generated SQL query. 6. Ask questions asterisk iterates through a list of questions and uses the db_chain.run method to get the answer from the database. 6. Best practices and considerations. Asterisk data privacy and security asterisk be mindful of data privacy and security when building text-to-SQL agents, especially when dealing with sensitive data. Implement appropriate access controls and data masking techniques. Asterisk user interface design asterisk design a user-friendly interface that allows users to easily ask questions and view the results. Asterisk error handling and feedback asterisk provide informative error messages to the user if the agent is unable to translate the question into a SQL query or if the query fails to execute. Asterisk continuous improvement asterisk continuously evaluate and improve the accuracy and performance of the agent by collecting user feedback and training data. Asterisk schema evolution asterisk handle changes to the database schema gracefully. Update the schema encoding and retraining the agent as needed. Asterisk domain-specific knowledge asterisk consider incorporating domain-specific knowledge into the agent to improve its accuracy and performance in a particular domain. Asterisk regular expression for data validation, implement regex for filtering possible SQL injection requests. 7. Conclusion. Building a text-to-SQL agent is a complex but rewarding task. By combining NLP techniques, database knowledge, and machine learning, you can create a powerful tool that empowers users to access and analyze data more easily. The examples above will get you started and give you an overview of what to expect. As you develop and train, consider the challenges and techniques highlighted above to improve performance and develop a robust and effective text-to-SQL agent. Remember to prioritize data privacy, security, and user experience throughout the development process. The LangChain example demonstrates how to create a much more capable agent with fewer lines of code. However, it does rely on an external language model, so it adds the cost and latency involved in sending requests to an external API. You can achieve similar functionality using open-source language models, but it involves more setup. Good luck. Okay, let's dive deep into building a text-to-SQL agent for smarter database queries. This is a fascinating area that combines natural language processing, NLP, with database querying, allowing users to interact with databases using plain English instead of complex SQL. Understanding the goal and components. Our goal is to create a system that can 1. Accept a natural language question, example what are the names of all customers in California who ordered in the last month? 2. Understand the intent and entities within the question. 3. Translate that understanding into a valid SQL query that can be executed against a database. 4. Execute the SQL query against the database. 5. Return the results in a user-friendly format. Key components of a text-to-SQL agent ***. Natural Language Understanding, NLU, module ***. This is the brain of the agent. It's responsible for parsing the user's question, identifying keywords, and extracting the entities, example table names, column names, conditions, that will be needed to formulate the SQL query. Often, this is based on large language models, LLMs. Database schema information The agent must have information about the database it's querying. This includes table names, column names, data types of the columns, primary/foreign key relationships, and any constraints. Without this, the agent cannot reliably translate natural language into SQL. SQL query generator based on the output of the NLU module and the database schema, this component constructs the SQL query. This is the core logic of the system. It's where the NLP understanding gets translated into structured query language. SQL executor this component takes the generated SQL query and executes it against the database. It handles the database connection, query execution, and retrieval of results. Result presenter the raw results returned from the database are often not ideal for direct presentation to the user. This component transforms the results into a more readable and user-friendly format, example a table, a list, a summary. 2. Technologies and libraries. Here are some technologies and libraries that are commonly used to build text-to-SQL agents. Python ***, the most popular programming language for NLP and data science. Large language models, LLMs are critical for the NLU module. Popular options include GPT-3/GPT-4, OpenAI powerful, general-purpose LLMs that can be fine-tuned for text-to-SQL tasks. Require an API key and payment. Llama 2, Meta an open-source LLM that can be run locally or on cloud platforms. Requires more setup but offers more control and cost savings in the long run. PaLM 2, Google another strong LLM with robust reasoning capabilities, suitable for text-to-SQL. Hugging Face Transformers a library providing access to a wide variety of pre-trained transformer models, including those suitable for text-to-SQL. LangChain a framework specifically designed to build LLM-powered applications, including text-to-SQL agents. It simplifies the integration of LLMs with other components, such as databases. SQL Alchemy a Python SQL toolkit and object relational mapper, ORM. It provides a high-level way to interact with databases, abstracting away the differences between various database systems, example PostgreSQL, MySQL, SQLite. SQLite a lightweight, file-based database. It's excellent for prototyping and small-scale applications. Pandas a data analysis library that provides data structures, like data frames, for working with tabular data. Useful for presenting results in a user-friendly manner. JSON a standard format for data interchange. The LLM will likely return output as a JSON string. 3. Step-by-step implementation, with LangChain and GPT 3.5/GPT-4. Here's a detailed code example using LangChain, OpenAI's GPT models, GPT 3.5 or GPT-4, and SQLite. Explanation 1. Setup import necessary libraries, LangChain, OpenAI, SQL database, etc. Asterisk set your OpenAI API key as an environment variable. Important asterisk keep your API key secure. Don't commit it to version control. Asterisk create a sample SQLite database named company.db with employees and departments tables. This part simulates having an existing database. You would adapt this to connect to your database. To initialize LangChain components asterisk SQL database.from_URI creates a connection to the SQLite database. The URI specifies the database connection string. OpenAI initializes the OpenAI LLM. Temperature equals 0 sets the creativity of the LLM to 0. This makes it more deterministic and less likely to generate unexpected SQL. Higher temperatures lead to more creative, but potentially incorrect, results. Verbose equals true, enables verbose output. This will print the intermediate steps LangChain is taking, which is extremely helpful for debugging. SQL database chain.from_LLM creates the core chain that links the LLM to the database. This chain takes the natural language query as input, uses the LLM to generate SQL, executes the SQL against the database, and returns the results. 3 ask_the_agent, query, function asterisk. This function takes the user's natural language query as input. db_chain.run, query, executes the LangChain pipeline to translate the query into SQL, run it against the database, and get the results. Error handling, includes a try, except block to catch potential errors during query execution. For examples and testing A list of sample queries is defined. The code iterates through the queries, calls ask_the_agent, to get the answer, and prints the question and answer. 5 Pandas integration, optional. The ask_the_agent_pandas, query, function improves the output using pandas. Instead of relying on the default text-based output from LangChain, it executes the generated SQL query using pdread_SQL_query. This loads the results directly into a pandas data frame. Uses df.to_string, to format the data frame into a readable string. This makes the results much easier to understand. Important considerations and improvements database schema the agent must understand the database schema. The SQL database.from_URI function helps with this, but sometimes the LLM needs more explicit information. You can provide more details by adding comments to the database tables and columns explaining their purpose. Explicitly specifying the tables to use in the SQL database constructor, example SQL database, engine, include _tables equals employees, departments. Providing examples of correct SQL queries in the prompt. Prompt engineering the quality of the LLM's output depends heavily on the prompt. Experiment with different prompt strategies to guide the LLM towards generating accurate SQL. Things to try. Include instructions like generate valid SQLite SQL to answer the question. Provide examples of question SQL pairs. This is called few-shot learning. Tell the LLM how to handle ambiguity or missing information. Error handling the try, except block catches general exceptions, but you can add more specific error handling for invalid SQL syntax. Database connection errors. Incorrect table or column names. Data type mismatches. Security very important, If you're building a text-to-SQL agent that will be used by untrusted users, you must implement robust security measures to prevent SQL injection attacks. Never directly execute SQL queries based on user input without sanitizing and validating them. Consider using parameterized queries or an ORM to prevent SQL injection. Also, limit the permissions of the database user to only allow the necessary operations. Context management. For more complex interactions, you might want to maintain a conversation history. This allows the user to ask follow-up questions that refer to previous queries. LangChain provides mechanisms for managing conversation memory. Fine-tuning. For optimal performance, fine-tune the LLM on a dataset of question SQL pairs specific to your database schema and domain. This can significantly improve accuracy. Complexity of questions. Simple questions like "What are the names of all employees?" are relatively easy for LLMs to handle. More complex questions involving aggregations, joins, subqueries, and window functions are much more challenging. You may need to break down complex questions into simpler steps. Other LLMs. Explore other LLMs besides OpenAI's GPT models. Llama 2, PaLM 2, and open-source models available through Hugging Face may offer better performance or cost savings for your specific use case. Tool use and agents. LangChain supports the creation of agents that can use various tools, including database access, search engines, etc. You could extend this example by incorporating other tools to provide even more versatile responses. Look into LangChain's agent documentation for more details. Example with few-shot learning. In this example, the example_prompt defines the structure of the interaction and provides a few example question SQL answer pairs. The question placeholder is where the user's actual question is inserted. This few-shot learning approach can significantly improve the LLM's ability to generate correct SQL, especially for more complex queries. Building a text-to-SQL agent is a complex but rewarding task. By combining NLP techniques with database querying, you can create a powerful tool that allows users to interact with databases in a more natural and intuitive way. Remember to prioritize security and carefully evaluate the performance of your agent to ensure accuracy and reliability. Good luck.